So let's take another look at this problem, finding the first and last position of element in a sorted array. So we talk about how to write our own binary search code to solve this problem. Now let's look at whether we can use the existing implementation of binary search in the libraries to solve this problem. So let's first look at C++. So it turns out that if you use C++, then this problem is fairly straightforward. So you essentially just call the library and then you can solve your problem. So you can use this function called the lower bound and upper bound. So these are in the C++ STL standard template library. So yeah, let me just go through the code. So again, we define answer to include the size to array -1, and if the given array nums is empty, they will just return that. Otherwise, we're going to use two iterator, low and up. So this will be pointers to the sort of like pointers, not quite point, but it's sort of like pointers to the element that first appearance of target and the last appearance of target. So we find them by using this calling this lower bound function. So this is the comment gives the description of the lower bound function. So it will return iterator pointing to the first element that does not compare less than the target. So that means it's greater than or equal to the target. So that's the lower bound. So you pass in sort of two iterator begin and end. So you're trying to find things in between these two, and you want to try to find this thing equal to target, find the target. So, and they will return something that is the first element that is greater than or equal to this target. So when this is the last, then that means none of the element is greater than equal to target. In other words, all the elements are less than target. So in that case, we'll return -1, -1. Also, this star low means we are going to find the value pointed by the iterator low. So sort of like dereferencing a pointer in C. So if this is not equal to target, that means the first element that's greater than equal to target is actually not equal to target. In other words, greater than target. That means target does not appear. So in either of this case, we'll just return the default -1, -1. So if we pass this condition, then it means that low actually points to the first appearance of target. So jumping slightly ahead, we'll actually compute the index by using low minus nums.begin. So the C++ library based on the iterator type will basically figure out the index. So and this is assigned to answer 0. So then to find the upper bound, to find the last appearance of target, we use the upper bound function. So this function will return an iterator pointing to the first element that is greater than val. So so the signature of the method is similar to lower bound. So we pass in two iterators, but in this case, instead of doing from the beginning, we can start with low. So passing in beginning will also be correct. This will just be slightly more efficient. And when this returns, then we know up is the first element that's greater than val. So the one before it has to be less than or equal to the target. So then that must be the last index, the last element that's equal to target. Because at this point, we know the target must appear. If it doesn't appear, it will return here. So then the last appearance of target will be up minus num_begin -1. So this is how we solve this using C++. Now, can we solve this in Java? Because Java also has a binary search. So Java has this binary search, and there are multiple of these. You can pass in array of different type. It will give you the using binary search to find the sort of the whether the element is appear, and if it appears, it'll give you an index. So according to the documentation, if array is not sorted, the result is undefined. So it will return something, but there's no guarantee what it actually returns. If it's sorted and the element is that you are searching for appears, it will return an index, so that the index must point to the element that appears. If the element does not appear, it will return a negative number, so that you can distinguish between appearance and not appearance by using the sign. And the value also has meaning, so it returns this negative insertion point -1. So the insertion point is defined as the point at which the key would be inserted into the array. So the smallest possible value of insertion point is 0. So that is when the value you have is less than everything in the array. So, and the biggest insertion point would be n if the array already have n element, if it's the biggest element. So this negative insertion -1 will take a value from -1 up to negative n minus 1. Negative n -1, so minus n minus 1. So however, when these targets appear more than once, so if the array contains multiple elements with the specified value, then there's no guarantee which one will be found. It will find one of them, but it will not guarantee whether it finds the first or the last. So essentially, it can use a very simple binary search. You compute the middle. If it's the middle element equals the target, you simply return. So you don't know whether that is the first one or the last one. So because of that, we cannot use Java's binary search to solve this problem.